Hello everyone. Hello everyone again. Now I'm gonna present you Roberto Orgio to do his presentation about async Kotlin.
Hello everyone. Can you hear me? Yeah, I can hear myself as well, so it's okay. So, thanks for being here. We'll be talking about asynchronous programming in Kotlin, and actually how hard, or maybe it's better to say easy, it is to do with the new coroutines. Okay? But first, let's take a few steps back. So, when we talk about asynchronous programming, what we expect is something like this. Like everything that is in the correct order, everyone eaten from the correct bowl, right? Problem is that we can't really say how it's going to end. And usually, what we get is something like this instead. So everyone eating somewhere, and it's quite messy. It's not really like, no, what we expected. But actually, there is a way in which we can have asynchronous programming behaving as we want it and as easy as synchronous programming. Would you believe that? No? No, you should say no now. Please say no. We don't believe you. No. No? Okay. Well, actually, yes, there is. So, before I can show you how all of these work, I have to introduce a concept. That is the concept of blocking and non-blocking waiting. So, let's check this code briefly. So, what we have here is something weird that is on the top. Then there is something that reminds us of waiting, like delay. So, we want to delay something. Then we have a printing instruction. We have another printing instruction, and then we have something that surely is a waiting call, right? Easy enough, right? Okay, so the first one, the delay, is actually a non-blocking call. What does it mean is that the whole stuff between the curly braces is going to be suspended, but the whole thread will keep working, while the second one will block the whole thread. That means that one will let our application work as expected. If we call the second one on the main thread, we're going to have a bad time, because it's going to block everything. So, this is almost crystal clear, right? Okay. So, we saw the blocking and non-blocking call. And actually, this is almost what we need, because this is a coroutine. Okay? So, we saw that we have a non-blocking call, and then we have some other instruction. So, with that concept, we can define a coroutine like a computation that can be suspended. So, what we have there with the delay is actually what we call a suspension point. And these kind of points are the only points in which we can suspend our coroutine. So, when we get there, what we say is that wait to execute the next instructions this time, that is 1 second. Okay? So, for creating a suspension point, though, well, we need a new modifier. Okay, now back. Okay, a new modifier. This modifier is actually the suspend keyword. This keyword makes our function behave like a suspension point. And marking a function as a suspend function means that we can only call it from a coroutine or another suspending function. So what we have here is a function, again, that will tell our coroutine to suspend its works while the rest of the thread keeps on doing its job. The last bit of information that we need in order to truly know coroutines is the launch part. This is called a builder. So to create a coroutine, we need a builder and at least one suspension point. Otherwise, we don't have a coroutine. Okay? So launch is our builder. What builds the coroutine? What instructs our app that we are going to use a coroutine? That we want to create asynchronous programming. While delay is a suspension point, the one that is going to suspend the execution of our coroutine without blocking the whole thread. But there's a catch, because of course, they are nice, they are easy, and we can definitely use them on Android as well. Problem is that they are not stable yet. They are experimental. So in order to use them, we have to first enable them in our Gradle properties file. Then we have, of course, to add our dependencies. But since this is not really enough, we also have to instruct our Gradle property file, our build.gradle file, to enable coroutines. So before we can start using them, we have to make these 3 steps, and then we can use coroutines. So far, we didn't really see anything life-changing, right? It was pretty easy, like a delay. We could achieve the same with any RxJava routine or any other asynchronous programming framework, right? So let's see if there is something that actually helps us a little bit more while creating Android apps. So this is more or less the same, right? There is only one thing that changes. Can you spot it? What is changing from this function to the other? There's a UI, exactly. So this UI here is an optional parameter of the coroutine builder that is called the coroutine context. It's not related with Android context, but they chose the same wording. So this context will tell our coroutine that we want to execute this stuff on the UI thread, so that we have native Android bindings directly baked into the coroutine. Okay, so we start getting familiar with something that we need, but again, we don't have anything that changes our life, right? So let's take this a bit further. Okay, so let's say that we want this routine to be cancelable, because of course, one of the main things of the coroutines is that we can cancel them. So that if we don't care anymore that their job is done, we can just say, hey, I have a reference to whatever you are. I don't need you to do your job anymore. Please cancel. So we have a method, the cancel one, that will take care of canceling the execution of the coroutine. So of course, we can create coroutines that are not cancelable, so they will keep on executing, but this is against the idea of coroutines. So all the coroutines we write should always be cancelable. So let's try and refactor this part so that we can actually reuse it. Because we are making progress, but it's not something that, it's really changing. So let's wrap the logic that we had earlier in a function. So Do you remember what that suspend keyword does? So, nobody remembers that suspend keyword? I do. What does it do? Suspension point, maybe? Yeah. That is. So, this function helps us creating a suspension point. Of course, here we are not suspending that much apart from the delay there. So, we are changing the value of our text view, changing it with a countdown. We wait at every iteration for 1 second, and then we print done. This is fairly easy. I mean, we have everything that we need in a suspending function. We are calling another suspending function from our suspending function. So we are pretty good to go, right? So once we have this function, we want to be able to actually pass it around. So we know how to pass a function in Kotlin, and passing a coroutine is not that different. So what we do is actually just add the suspend keyword to our function parameter, and this will be passed to our, in this case, extension function. So what we have here, we have our suspending function that will create a countdown and wait every iteration for 1 second, and we have this extension method that will set a click listener and will give our results back to the UI, because we all know that if we try to access our view out of the UI context, it's gonna end badly. So we are sure that this one works. So we have our suspending function that we call action, and we invoke it inside the builder with the correct context, right? Then we just link them all together with a very, very nice notation. So it's fairly easy, right? Okay, but still, would you use it in production? No, you are not sold yet, right? Well, let's see if I can actually sell you the coroutines so that you want to use them in your everyday job. Yes?
You said coroutines are experimental.
Yes.
Can you use it in production?
Yes, I do. But that is a question that I will answer later in the slides. But yes, I do. So let's see if there is at least some other example that I can give you so that I make you want to use the coroutines. So, well, actually, there is at least one example. So, okay. So this is a sample app that only checks for the weather. So what we do here is, I don't know if you saw that there was a progress bar. Did you see it? No? Let's try again. Yeah, it was very subtle. I could have made it a bit bigger, right? So what we do here is showing our view and then retrieving the weather in the city where I'm from. So to do so, I used mainly two components. One, of course, is coroutines, and the other is retrofit, because we all know retrofit, right? Yes. That was a tricky question. So, okay. So I'm telling you that I can use retrofit, but I didn't show you how. So let's see how we can do that. So this is the function that is run when we click on the button. So let's remove the part that we don't really, we don't really want to know, because, I mean, this is simple Android stuff, just showing and hiding view. It is pretty easy. Everyone knows how to change visibility of a view. But there is a bind UI to response. This is a simple method. I mean, we can do that in any view holder, any compound view, wherever we want, right? So let's see what really matters for what concerns coroutines. So, and this is this small part. So if you remember, in the previous example, we were passing a function that was returning a unit value, right? This time, we are passing something strange, right? This is the ferret thing that we didn't really mention earlier, right? And also, there is this strange await method there. That's because we were using before only the launch context. That is a fire and forget one. That means that we don't want to have the result returned to us. We just say, hey, run this, I don't care about the result. Just do your job. And the job is exactly what launch returns us, so that we can cancel this job and we are not waiting for any result. But actually, in this case, we want the result. So the launch builder was not enough. So we had to change something in the way we used coroutines. And what changed is actually this one. So this is the function that we are passing to our builder. So as we can see here, we have this async call. Async is a builder as launch. The only difference is that the return type in this case is a deferred, and the type returned by getWeatherSync, so it's a deferred response. So it will return a value, and mostly that's it. That's the only difference. It will return us a value, so that we can call the await that will tell our code suspend until you have a result. As soon as you have the result, return it to me and use it. So what we had there, we had something that was running on the UI that said, okay, make this a synchronous request and stop worrying about executing your code. As soon as you have the response, keep on going and change the UI. How can all of this be possible? Because coroutines are what JetBrains loves to call lightweight threads. So we can run, well, they say they can run up to 100,000 coroutines at the same time, and I'm pretty sure that we cannot run as many threads. How it works internally is a bit out of scope for the talk, but they actually manage threading so that we can launch a huge amount of coroutines and we can suspend them. Of course, we have a trade-off for this. We can suspend the thread whenever we want, and we cannot suspend coroutines whenever we want. We can only suspend them at, I couldn't hear you. Good. That was the answer. So the trade-off is that one. We can run multiple coroutines at the same time, more than we actually can run threads, but we can only suspend them at specific suspension points. Okay? And of course, this getWeatherSync is just a synchronous retrofit call. So we are not using any observable, any callback, just a simple call and the type of response we want. So if we execute this getWeatherSync in our Android application without changing its thread execution, well, we're going to have a very good network on main thread exception. And of course, luckily, there is incoming native retrofit support for coroutines. That means that we won't have to type async and the synchronous call ever again, because it will be baked directly into retrofit. So our retrofit instance will return us a deferred of the type we want. That will be quite easy to do. I mean, imagine just calling our retrofit service dot make this call dot await. It's quite good, right? Okay, but so far we didn't mention anything about testing, right? Did I talk about testing? No, right? I did not. Okay, so we all know that testing asynchronous code is not easy, right? I mean, I test RxJava pretty often, and if you don't do that properly, it's pretty hard. I mean, it's not that easy to have your test running fastly and in a reliable way. Luckily, we have another context builder that helps us exactly in this way. And this one is run blocking. What happens inside run blocking is that what it says is that this is a coroutine, but please, don't mind it. Just execute it synchronously, because I really want that to be in this way. So we saw the fire and forget builder, that is launch, the please do this and return me value builder, that is async. Come on, we saw 3 builders so far. One is launch, one is run blocking. What is the third one? Good, good, okay. So we have the fire and forget, which is good. The please do this thing and return the result to me, that is. And please just do it now, I want it to be blocking, that is. Okay, amazing. And they can only be suspended at? Oh, amazing. You know, mastered coroutines. So, well, actually, but that was due. I mean, I had to do that. There is one more trick that I wanted to talk about, because coroutines are scheduled to be executed immediately, so that they are faster to return the result. I mean, as soon as we create a coroutine, it is scheduled for execution, so that the first time we call await, we already have the result. But maybe this is not what we really want. Maybe we want them to be executed only the first time that we actually call them. Exactly. They can be lazy. How can we do that? Okay. I'm having some issues with changing slides today. Well, we have another optional parameter in the builder, because there is still our builder, that instructs the coroutine to start the first time we call await. So, with this parameter, it is not scheduled to run as soon as we create it, but only the first time we call await. But what is the trade-off with this? Imagine that we are depending on 2 different results from network calls. So if we created the 2 vals, like, let's say, weather and traffic, and they are both based on the async builder. As soon as we call await, well, they are actually already executing, so we have the results pretty fast. If we make both lazy, well, that means that the first one is executed, then when we have the result, the second one is executed because we call await. So, I mean, we lose quite a lot of time. So, I mean, we have a lot of stuff to use coroutines, and we can make them behave as we want. So, well, just remember that they exist. So, to answer your question from earlier, well, there is only one possible answer to this, and the answer is this one. Oh, wait, no, it's not that. The answer is actually yes. We should use coroutine. They are stable enough. They don't crash as often as someone would expect. I never had any problem with running them in a production code. And I think they make the code much more readable than other asynchronous framework. I'm a heavy RxJava user. I'd have to say that I really felt in love with coroutines because they are really easy to learn. Of course, we don't have all the operators, but if we need something simple, something fast, and something reliable, well, we have another option now. So, I didn't mention that earlier, but I'm in the New York Times team, in the Android team. These are all our links. And if you want the slides for the presentation, they are available at that link there. So if you have any questions, feel free to ask them now. No more questions? Okay, we have a question. Yeah.
We can change our variable, and the variable make changes at its observers. Is async, and what do you think about the new components?
You mean live data?
Yeah, exactly.
Oh, well, actually, I love architecture components. I'm a fan more of the lifecycle observer. Well, I think that live data are good when you want to transfer your data from your business logic to the UI. Because if you want to do a networking request, I think that is a bit out of scope of live data. Because, I mean, you only have 2 operators as of today. Of course, you can create more, but it still relies on you. So you have switch map and map. And if you want to do some heavy lifting there, you really need to write your own code. So I think they work very well, but for very specific cases.
Thank you.
Other questions?
You said the coroutines are still experimental.
Yes.
Do you know about the release schedule? When do you think they will get stable?
In the future, definitely.
Okay, I should call a wait then.
No, you should start scheduling them. Other questions?
Which one do you prefer more, RxJava or Coroutines?
That's a tough one. Actually, it depends on what I'm doing. So far, we are using pretty much only RxJava. But if I were to only create like a network framework for all our requests, most probably I will go on coroutines. Just because they are simpler to learn, they are simpler to use, and actually I think they are more readable. I mean, RxJava is good when you are doing some heavy lifting of your data, so you're transforming in multiple ways.
You have a lot of operators.
Sorry?
You have a lot of operators.
Yes, but it depends on what you're doing. If you just need a network request, you can use a coroutine. But actually, nothing tells you that you can't use both at the same time. Other questions? Okay, thank you all for being here.